So this is Algebra 1, Semester 1. It's the third unit called Graphing Linears. Linears is another name for lines. And it's the 12th lesson, Graphing Absolute Value Linears Practice. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So usually at this point I try to show where those notes are on the website because they can be difficult for students to find. So this is the name of the website. It's creatormath.weebly.com. If you Google that, you should be able to get to this homepage here. It should look like this. Any questions you have about the composition book? Students are always trying to figure out what goes where and how to number pages. Scroll down till you see the words composition book. Follow all the directions, watch all the videos, and adhere to the turn-in dates, as well as put things in the place where they belong. And then put the notes into the comp book, which we're going to go to now. That's under the tab for the class, or in this case the video we're making. Under those tabs you will find vocabulary, practice sets, which is where we're going to go over one right now, videos, which we're making right now, and notes. All right, so we're going to show how to find all those. If you're not getting 100% on your vocabulary practices, you may not know there's a PDF right here of all the vocabulary words we use for the entire year. It is downloadable to your device. It is searchable, so Google how do I search a PDF and type in the type of device you're using because it's a little bit different with each device. Now we're going to scroll down and look for the semester. That's the next most important thing. This is the semester for the video we're making right now, and the class you're in, if this is the right one for you. This is the table of contents. This is very important, and it's what you're going to write. You're going to copy this entire table of contents onto pages 2 through 6 of your composition book. If you haven't done that by now, you need to stop this video and attend to that right away. The importance of the table of contents, even though it's long, it's about 3.5 pages long for those pages 2 through 6. It tells you where everything goes by page number, including units, lessons, etc. Right, so now we're going to scroll on down to the unit we're in, which is graphing linears. We're going to go to the lesson we're in, which is graphing absolute value, number 12 right here, graphing absolute value linears. Here's the pages that the notes go on. Please don't take this video's word for it, but look at the actual table of contents on the website at the time you're viewing this. These page numbers probably will have changed. Here are the notes. Here's the problem set we're going to go over, and the video lesson will be tagged here or linked here. When you open notes to copy those into your comp book, sometimes I have to do it twice, and this is one of those times. So see how it's not clearing up? This is not loaded yet. Knock on wood, I've always been able to do it in 2 or fewer times. So graphing absolute, let me open the same one again. Okay, and so see how it cleared up. Now we can expand it, we can see all the notes. So go ahead and put this into your composition book on the correct pages as shown, described how to look up and find, I guess. Given that y equals absolute value symbol are 2 bars. We've done other lessons with absolute value in it, so this should not be new to you. However, if you're remembering it, absolute value is the distance that a number is from 0 on the number line. So it's never negative, because distance can't be negative. What we're going to do is graph these equations on Desmos.com to see how everything plays out. So we're going to use Desmos, and we're going to play with this absolute value. In fact, we're going to use different things. We're going to do the absolute value of x plus 1, the absolute value of x minus 1, the absolute value of x plus 1, right, that total value, the absolute value of x minus 1, the absolute value of x plus 1 outside of the absolute value, all right, and so on and so forth, all right. So put those into your notes, and that'll help you at least be familiar with writing this down and sort of seeing the notation. Here's definitions, absolute value. The 2 vertical bars is the symbol for absolute value, and we're going to Desmos.com to graph this. So the actual lesson on absolute value was prior. This is a little bit more advanced where we're actually graphing absolute value equations. All right. So with that, let's look at the first problem and see what we have here. If I can fit everything in, it says graph the following absolute value equations on Desmos.com and match up the correct equation with the shown graph. So it's a little bit hard to see here with some of my graphics. This one is a graph. There's an absolute value graph right here and here. Now the question is what's going on. So let's go down, let's look, let's go straight for this answer and say y equals absolute value of x. Let's go to our device and go like this, this, and this. There we go. Let's clear out these from something else we were working on, and let's type in y equals, okay, that would help. Come on. It doesn't want to focus. Maybe it needs more light. Let's give it more. There, how about that? There we go. All right, that might be it. So let's go back here. Let's go back to Desmos. Oh, okay. Crashing on us. Everything always happens at one time. All right, so we can see this, we can see the graph. Here's our graph, and y equals absolute value of x. We're going to start with that straight from the notes, and let's say y equals, and notice they have an absolute value symbol here. We're going to put an x between it and close it. So notice the vertical bars, just like in our notes, and notice the graph that is produced. Looks just like the one we've got here, right? So to explain this, we're going to try to talk about what absolute value is. Absolute value wants to take the distance something is from the number line, and it can be, the effect students learn is, oh, it turns a value positive. So let's take some values. Let's go here to 1. So if x equals 1 right here, and we plug that in, the absolute value of 1 is 1. So you're going to go up here, and it graphs right there, right? If we go to 2, the absolute value of 2 is 2. The absolute value of 0 is 0. So this one makes sense to students. Here's where the interesting thing happens. If we go backwards to x equal to -1, the absolute value of -1 is 1, positive 1, so it's up here. The absolute value of -2 is 2, so it's up here. So all of a sudden you have this V-shaped graph, right? Very interesting and very fun to look at. So this is what we're talking about when we're talking about graphing. Now, why does -1 return a positive 1? So just a reminder, say this is 0 and this is -1. The definition of absolute value is the distance between this -1 and 0 on the number line. How much distance is here? 1. Notice that distance is not a negative number. In fact, if you think about the distance between you and some object, and then try to consider it being negative, there is no such thing. There is no such thing as a negative distance. That's because negative describes a direction, not a magnitude. And when you get to physics and you talk about vectors that have direction and magnitude, you'll be trying to use negative to describe which direction. It turns out we go to the left to be negative on a number line. All right, so that's what we've got for absolute value of x. Let's move to the next and see how this progresses. So the next one we're going to graph is, now all of a sudden, look at our graph. The absolute value v is not at 0 anymore. It's up here at 1. How could this be? Well, let's take this one and consider it and just type it into our Desmos to see what happens. Let's say plus 1. Notice that it jumps straight up here, and the v is now at, here's 2, so this must be 1 right here, right? So in fact, you can play with this very quickly. Let's just put a 2 in, right? There it jumps to 2. What if you put a -1? Oops, let me put my absolute value back. Let's do -1. It jumps down to -1. So this control set of this equation, I can adjust this to move this thing vertically up and down, this number here outside of the absolute value. All right, so using your calculator, we typed in -1. We saw that wasn't it. We used this on the prior. This one says -x, and let's do that really quickly because that's where this lesson is going to go. Let's get rid of this -1, and let's put a negative in front of the absolute value. Let's put it right here. There you go. It flips the v upside down. So see this one here, this option of negative right here? That's not going to be this one because this one's opening up rather than opening down. All right. Let's move to the next. So again, we're given one, and you might start to get a little bit intuitive already about this. Here's this one down. This v is intersecting at -1. So guess what it is? It's the one we already graphed. We already know what it is because we looked at it on the calculator. And we can type it really quickly. That's the great thing about Desmos. We don't have to spend a lot of time. We just say -1. There it is again, crossing this v is intersecting this -1. And we can plug in 0 to this, right? If we plug in 0 here, the absolute value of 0 is 0. -1 would mean at 0, this would be -1. If you plug in 1 here, 1 would be, the absolute value 1 is 1, 1 minus 1 is 0. So there it is at 0. If we plug in 2, the absolute value of 2 is 2, -1 is 1. So there it is there at 1. And then notice if we go backwards to -1, -1 the absolute value is +1 because it's distance on the number line from 0. So +1 minus 1 is 0, back to 0 here. And if we go to -2, that would be a +2 because that's the distance on the number line to -2. And 2 minus 1 is 1. So anyway, all this maps out pretty easily and quickly once you get the gist of what's going on. Before this, it looks like a strange notation. Now here we are, it's upside down, opening downward, and at 0, we already know this is this one. It is y, it's hard to see, equals a negative absolute value of x. Okay, that's a negative right here. There we go. Let's see what other problems, but these are kept pretty simple for us. You'll do a lot more of this in Algebra 2, but this is a great introduction in Algebra 1. So now we have an interesting thing. The v is not here like we saw before, right? The v has been moved -1. So notice that our 1 is now moved inside the absolute value symbol. Let's try it. So get rid of the 1 out here, and let's put a +1 inside, +1. The interesting thing is that by putting a +1, the v moves 1 to the left. Isn't that interesting? It's opposite. So if we had, in fact, if we do a -1, what do you think is going to happen? -1 will shift it over this way is what it should do, right? Let's see if it does. Let's do -1. Sure enough, it seems to be opposite and is opposite whatever sign is in the absolute value. And let's just try it out. If this is x equal to 1 here, then it would be 1 minus 1 is 0, and absolute value of 0 is 0. That's why we have a dot right here at 1, 0. Go to 2. 2 minus 1 is 1, and absolute value puts this dot right here at 1. Let's go backwards. Go back to 0. 0 minus 1 would be a -1, but because it's an absolute value, which is the distance from 0 on the number line, it would just be a 1. So pop up here and put a 1. All right, so hope you're seeing this is consistent, and interestingly enough, very simple numbers. You can kind of see this. You can see this. Now we have it opening down. Look at this. It's opening downward, so I need to see a negative. No negative, no negative, no negative. See the negative right there? I already know it's this, and then this +1 says that it was here, and now because it's the opposite, it's minus, it moves 1 in this direction over this way, right to here. So that's our answer. We can now graph this without even using Desmos, although we will plug it in quickly because it's so easy. There's +1, that moves it here, and let's do the minus out in front, and that flips it upside down. Okay, and how many more do we have? Okay, so this one's opening up, so it's got to be a positive. It looks like an x, but it's over here to the right. So can we say that it's going to be inside the absolute value symbol x minus 1? Right, just check it to make sure. I'm very sure because I now know the pattern. And there we go, it's moved over. There it is, right there at 1. Let's do another. All right. Wow, they're taking it up a step on us. Okay, so now this has gone to the right 1. So I can imagine an x minus 1 inside of the absolute value. And it's gone down 1, 2. So how about a -2 outside of this and a y equals, and look at this, y equals x minus 1 plus 2? No, it's not +2. That's wrong. Let's check it. This is great. We found one we can check. So x minus 1 is opening up. That's good. And let's put in a -2 here. Let's try the answer I wanted to do. And sure enough, it's being brought down 1, 2. So that's this one. This has got to be a minus right here. Okay, and I will fix this before you get to this assignment. All right, that's why I'm a little bit ahead of you on the assignments. Okay, so To get this right, make sure you're matching up the title of this video, Algebra 1, Semester 1. It's the 3rd unit called Graphing Linears, and it's the 12th lesson called Graphing Absolute Value Linears Practice. It's on creatormath.com under the Algebra 1 tab. Hope this helps.